Okay, today we're going to talk about piecewise functions. And a piecewise function is divided up into pieces. And in this case, there's 1, 2, 3 pieces. Each one of these pieces is actually an equation of a line. Now, what's unique to a piecewise function is this part here. This part tells you the domain or the places on the graph where each one of your individual pieces of the graph takes place. For example, our first piece, 3x plus 8, takes place on the graph between 0 and 3. Our second part, x plus 14, takes place on the graph between 3 and 6. And f of x equals 20 takes place on the graph when x is greater than 6. So if we just use some values for x in these examples, I'm going to write some in. And we'll plug in each individual x into the equation that corresponds to the region where x falls. So for instance, f of x is now f of 0. We want to know when x is 0. X is 0 right here in this part of the graph, so we're going to plug it into this equation, 3x plus 8. When we solve that, we get the answer of 8. The second one, f of 2, that will also fall in right in here, in that domain. So we're still going to use that same equation, 3 times 2 plus 8, and in this case, the total will be 14. Now in our next example, f of 4, when x is 4, falls right in here. So we're going to use the x plus 14 equation, so 4 plus 14, or 18. The next one's a little tricky because our x value is 6, but if you notice in this domain, x equals 6, in this domain, x is greater than 6. So 6 does not fall in this category, it falls up here into this one. So we're going to plug 6 in for x, so 6 plus 14 equals 20. And the last one, f of x is 8. It will fall into this domain because anything greater than 6. And anytime you plug anything into that, you actually can't plug it in because the answer will just be 20. For these next examples, I'm going to use negative 2, 1, and positive 2. So when x is negative 2, it will fall in here. So I will use the 3x, 3 times negative 2 minus 1. That's negative 6 minus 1, or negative 7. When the value for x is 1, I'm going to use it right here. X is equal to 1. Here, x is greater than 1. So I can't use this one. I have to use this equation, 3 times 1 minus 3, or 2. In my last example, my x value is 2, so I'll use it in this equation here, this domain, and the value for any value of x is 4. I'm going to use the values negative 1, 2, and 10. In this case, negative 1 falls into this domain, x is less than or equal to 0, so I'll use the equation 3x, or in this case, 3 times negative 1, or negative 3. When my x value is 2, it's going to fall into that domain, so it'll be 2 times 2 plus 2, or 4 plus 2, or 6. The last value I'm going to use is 10, so that will fall into this domain, anything that's greater than or equal to 4. So 4 times 10 minus 2, which is 40 minus 2, or 38. Okay, now I'm going to mix it up a little. I'm going to use 6, 3, 1, and 5. So when my x value is 6, I have a 6 here and I have a 6 here, but this is the only one where it equals 6. Here it is less than 6, so I'm going to use the equation 4x, or 4 times 6 is 24. In this case, f of x, x is 1, well, that will fall into this domain here. So 3 times 1, or 3. I used this equation. The next one is f of 3, so 3 will fall into this domain here. So it's 3 minus 4, plugged in for x, be negative 1. And my last one, f of x is 5. X is 5, so I'm going to use this one because this is where it equals 5. Here it's just less than 5. So at any value of x in this piece of the graph, my y value or my function will be 2. Okay, so I hope you guys got that. We're going to go over it again tomorrow, and I will check to see if you actually listen to this tomorrow morning. Okay? Bye. Bye-bye.